Welcome everyone. I am Anil Anthony, Assistant Professor, Department of Computer Science and Engineering, Jyoti Engineering College. Here I am going to discuss the topic Introduction to Algorithm. So, what is algorithm? So, algorithm is step-by-step procedure to solve any problem. Then we will discuss the difference between algorithm and program. The program also having the same definition. So, the step-by-step procedure to solve any problem. So, what is the difference between these two? Algorithm is written at design time and program is written at the implementation time. A domain knowledge is required for writing any algorithm, but in program, the skill of the programmer, the programming skill of the programmer is enough to write any program. The language which is used in algorithm is either English-like language or mathematical notation. For program, it requires programming language like C, C++, Java or something like that. For algorithm, it is hardware and operating system independent, because algorithm is for any problem, but program is writing for any computation problem, so it is totally dependent upon hardware and operating system. Efficiency of the algorithm should be analyzed by using paper and pen, but the program efficiency can be tested by testing tools. So what are the characteristics of the algorithm? The characteristics of algorithm means it is satisfying characters like input, output, definiteness, finiteness and effectiveness. Input in this meaning 0 or more quantities are externally supplied to an algorithm. Output, at least one quantity is produced. Definiteness, each instruction is clear and unambiguous. Finiteness means algorithm should be terminated after finite number of steps. Effectiveness, every instruction is very basic, should be carried out by any person using paper and pencil. So what are the two different desired properties of algorithm? One is correctness of the algorithm. It always provides the correct output when presenting with legal input. The efficiency of the algorithm, it computes correct output quickly for a given input. And how we are going to analyze an algorithm? Analyzing algorithm means predicting the resource that algorithm requires in order to execute. So what are the resources required for an algorithm? It should be time. The time required to execute an algorithm. Space, amount of memory required to execute an algorithm. Network, the network nowadays, the network means the where computation can be done in a cloud or some other platform. So network or a remote place. So network is a parameter which is used for analyzing the algorithm. Power, the amount of power required to execute an algorithm. The power is another constraint which is there for finding the efficiency. And CPU registers. CPU registers in the sense that some of the program required so many registers that makes the algorithm even faster. And there are n factors are there to execute the or analyze an algorithm. But the factors, that is important factor to analyze the efficiency of the algorithm is time and space. Why? Because the other factors is totally dependent upon some external parameters. For example, a network is dependent upon the how the resource is used in the cloud, or how the resources are used in some other network remote station. So that also depend on the external factors, or registers, or some that is depend upon the machine. If it is power, means that also depend upon the high-end machine which is used. So all depend on these factors, but time and space is independent of all these factors. That's why it is an important factor to analyze the algorithm. So these two factors will be run as a function of length of the input. This is the way we are analyzing the efficiency of the algorithm. What are the types of algorithm? There are two types of algorithm: iterative algorithm and recursive algorithm. Iterative algorithm means it contains loop statement, and recursive algorithm, as you know, recursive function, it calls the same function again. That is called recursive algorithm. That are the two type of algorithm. And to analyze the different two algorithms types, for iterative algorithm, what we are doing is that we are counting the number of loops that is executed, and counting that loops we can analyze the algorithm. And recursive algorithm means if you have any function that is calling again, that can be analyzed by using recursive equations. All other program statement other than recursive call and some iterative loop statement, other statement is considered as a constant. So complexity is analyzed like this. Then we discuss space complexity. Space complexity of the algorithm, amount of memory needed to run to completion. There are two parts in this when we analyze space complexity. One is fixed part and other is variable. Fixed part in terms of number of input and output, or that is independent of input and output. For example, for a loop statement, it will execute from 1 to n. It's not totally depend upon, not at all depend upon input and output. But variable part means what all variable we are using to execute that program. So that is a variable part. So that total will have that will determine the space complexity. For this, an example of space complexity analysis, an algorithm sum contain for one for loop. So n is a constant part, variable part a, s and I, three variables are used for. So we can say that 1 plus 1 plus 1 constant time 1 plus 1 plus 1, it is 3, n plus 3. In other words, 3 can be neglected as far as n is there, because n is the function input size, so that is much larger than this small 3. So space complexity equal to n. Time complexity, the estimation of number of steps performed by given computation depend upon size of the input data. Time complexity is the amount of computation time needed to run to completion in terms of amount of input to the algorithm. The total time should be compile time plus run time. So these are some of the time complexities which is used. One is constant, the notation is order of 1. Then next is logarithmic, order of log n. Another is linear, order of n, it is proportional to the input data. Quadratic, order of n square, square of the input data. Cubical, order of n cube, size cube of the input data. And big one is the exponential. Exponential means 2 raised to n, k raised to n, n factorial consider exponential number of operations. And we are discussing some more time complexity, which is a simple one to analyze. This is an example for iterative algorithm. In this complexity, we are only concerned about the number of loops. If it is an iterative algorithm, there is only one loop is there, for loop is there. It values taken from 1 to n. So time complexity is order of n or n. In the second example, here also one for loop is there. We can directly say that this is n. There is one checking is inside the for loop, but this checking can be done n iterative, because the for inside for loop if statement is there. So if does not have any effect other than iterating the n element. So here also time complexity is order of n or n. In the case of next example, we have two for loop and if statement. Two for loop means one side one for loop and one more for loop is there. So it runs in quadratic time, order of n square. In the another example, that is also a simple one, direct one. There are 3 for loop means it time complexity remains as n cube, order of n cube. And another example, here also 2 for loop, you can directly say that order of n square, but the difference in this problem is that one is executing n time and other is executing m time. So the complexity of this is order of n into m. So that is another example. That's all for today's class. Thank you for watching.